Welcome to MSP Academy. This video, I'm going to tell about the 8253 programmable interval timer. So we go into the video. So what is the need of this 8253? So 8253 means it is a programmable interval timer or counter. It can be used for two purposes. Either it can be used as timer or it can be used as counter, and it is specifically designed for use with Intel microcomputer systems. So the main purpose of counter or timer is it is used to produce the accurate time delays. So already many microcomputer systems may have the problem in producing accurate time delays. This 8253 solves that problem of generating the accurate time delays under the software control. And also it is easy to see that software overhead is minimal here, and that multiple delays can easily be maintained by assignment of priority levels. And this is a block diagram of the programmable interval timer. The IC number that is used for programmable interval timer is 8253, and one more IC number is available for programmable interval timer, that is 8254. And this block diagram contains 5 sections: data bus buffer, read write logic, then control word register, and different counters. There are 3 counters which are used in this block diagram: counter number 0, counter number 1, and counter number 2. So these are the 3 counters that are used in this block diagram. We will see one by one what is the use of every block. First one, it is a data bus buffer. So in data bus buffer, how many signals that are used in a data bus buffer is there are 8 signals, D0 to D7, all are bidirectional. So it is a 3-state 8-bit bidirectional data bus that is used when writing control words and count values and reading count values upon the reception of write and read signals from the CPU. For that purpose, this signal is used. The use of that signal here is it is D0 to D7. This is a bidirectional data bus buffer signal. 8 signals that are used. And the next one, it is a chip select, CS. In signal, what is the signal name is? It is a CS. CS denotes for chip select, and it is the data transfer with the CPU is enabled when this pin at a lowest level. And the next one, it is read and write. So read and write, what is the use of read signal is the data can be transferred from 8253, that is a programmable interval timer, to the CPU when this pin is low, that is when this pin is 0. Read complement signal, this is actually the complement signal. So when this signal is 0, what is the meaning is the data can be transferred from 8253 programmable interval timer into CPU. And the next signal is a write signal. The meaning of write signal is here the data can be transferred from CPU into 8253. The data that is written is happening here. So whatever data the CPU wants to write into 8253, so whenever this pin is at a low level, so it can be used to transfer the data from CPU into 8253. The next signal, it is A0 and A1. So this is a signal A0 and A1. So these two signals are used to decide which counter is used to read and write. It is A0 to A1. One of the 3 internal counters are the control word register. It is selected by A0 or A1 combination. And this is a table that indicates the decision of counter. Suppose A0 value is 0 and A1 value is 0. If it is 0, 0 means the result is counter 0, counter number 0. If it is 0, 1, it is counter number 1. And 1, 0 means counter number 2. And 1, 1 means it indicates the control word register. And XX means it indicates no selection. That is A0 value, address 0 value is 0 and A1 value is 0 means it indicates counter 0. 0, 1 means counter 1, 10 means counter 2 and 11 means control word register. And this is the table that indicates a control word register. As it is, this is a control word register here. Whatever input we got from the read write logic, that will be passed on to control word register. Depends on the value of the control word register, corresponding operations can be performed. I will tell what is the operation that can be performed. And here A0 value 0, A1 value is 0. If it is 0, 0 means it indicates counter number 0. And 0, 1 means it indicates counter number 1. And 1, 0 means it indicates counter 2. And 1, 1 means it indicates control word register. And here, as I told, whenever read, this is actually the complement signal, read RD dash and WR dash. If this is a complement signal, RD bar and WR bar and CS bar. And here, whenever RD complement value 1 and WR complement 0 and CS complement 0 means writing the value into the counter. And again, this is again writing counter 1 and this is writing counter 2. And again 1 1 means A0 value 1 and A1 value is 1 means writing into the control word. Whenever the CPU wants to perform the read operation from the counter, this value, that is read complement value, is 0. The read bar value is 0 and the write bar value is 1. So whenever it is 0 1, reading the value from counter number 0, okay, that is 0 0. A0 value 0 and A1 value 0 means reading the value from counter number 0. And 0 1 means reading from counter number 1. And 1 0 means reading from counter number 2. And 1 1 means it indicates no operation. This is control word register table. And it depends on the value of A0, A1, read, write and CS. The corresponding operations can be performed. And the next signal, 3 signals are used in counters, each counters: clock 0 to 2, gate 0 to 2 and out 0 to 2. What is the meaning of that signal is, whenever the clock, what is the meaning of clock is, it is a clock input. The purpose of this clock input is it is used to supply 3 clock signals to the 3 counters. Whenever the clock signals need to produce, the 8253 use this signal for producing the clock signal. Then gate signal, again gate 0 means it is for counter 0, gate 1 means for counter 1 and gate 2 for counter 2. So gate 0 to 2, it is a gate input signal. It is control of starting, interruption and restarting of counting in the 3 respective counters in accordance with the set control word contents. This is gate values. The main purpose of this gate signal is it is used for control of starting of counter, interruption and restarting of counting. And the next signal is out signal, counter out 0 to 2. It is a counter out signal. It is the output of counter output waveform in accordance with the set mode and count value. So we have different modes are available. The purpose of the data bus buffer, as I told, it is used for programming the modes of 8253 and loading the count registers and reading the count values. This is about the architecture. So I will summarize. Here the data bus buffer, we have 8 signals. Then power supply and ground. Here we have a power supply and ground. VCC denotes for power supply and GND denotes for ground signal. Then read write logic, there are 5 signals: write, read, A0, A1 and chip select. And the control word register, whatever value that is given to the read write logic, that will be passed on to control word register. And 3 counters are used, 16-bit counters. For each counter we have 3 values, 2 input and 1 output. Clock 0, it is an input signal, and gate 0, again it is an input signal, and out 0, it is an output signal. It is for counter number 0, and this one clock 1 and gate 1 for counter number 1 and out 1 for counter number 1. Again clock 1 and gate 1 are input and out 1 is the output signal. Then counter 2, clock 2 and gate 2 are the input signal, and out 2, it is an output signal. So that's all about the operation of the programmable interval timer. If you have not subscribed this channel, subscribe and click the bell button to receive the all my notification, all my video notification. Thank you all.